Hello, welcome back again to the channel. On this video we're gonna discuss of how to solve this problem. Okay, so we're gonna use induction to prove this inequality. So first we can easily see that for the base case, which is for n equals 1, it's clearly true that the left hand side is greater than 1, because the left hand side is equal to 13 over 12 when n equals 1. So now let's assume that the statement is true for n. Assume it is true for, let's say, n equals k. So to make it easier to comprehend the induction hypothesis, which means that the sum from the reciprocal of k plus 1 all the way to the reciprocal of 3k plus 1 is strictly greater than 1. And now we wish to show the similar inequality for n equals k plus 1. So for n equals k plus 1, let's just look at the left hand side first. Okay, so the left hand side is gonna be, we're gonna replace each of n that appears here by k plus 1. So we have 1 over k plus 1 plus 1 plus 1 over k plus 1 plus 2 and so on, all the way to 1 over 3 times k plus 1 plus 1. Okay, so let us simplify this expression. So the left hand side will turn into 1 over k plus 2 plus 1 over k plus 3 all the way to 1 over 3k plus 4. Now we wish to use the induction hypothesis somehow, this inequality. So to make use of this inequality, we're gonna force the left hand side of this so that it has this kind of expression. And we can see right away that this expression is starting by 1 over k plus 1. Meanwhile, in order to use this expression, we need 1 over k plus 1. So in order to make 1 over k plus 1 appear on this expression, we just force it down here. So let us write down 1 minus 1 over k plus 1 to compensate the 1 over k plus 1. So this is just 0. And then we add 0 to this left hand side, and so on until 1 over 3k plus 4. Okay. So, but now this expression is starting from 1 over k plus 1 and end up with 1 over 3k plus 1. Meanwhile, here we have 1 over 3k plus 4. So before this 3k plus 4, we have 1 over 3k plus 3, 3k plus 2, and 3k plus 1. Right? So let's rewrite this as 1 over k plus 1 plus 1 over k plus 1 all the way to 1 over 3k plus 1. And there are some extras, which is what? 1 over 3k plus 2. Let me write down here. I think it might be enough. So 1 over 3k plus 2, 1 over 3k plus 3, and 1 over 3k plus 4. Okay. And we know this guy is greater than 1, strictly greater than 1. So we will be able to show that the left hand side is strictly bigger than 1 if the rest, which is this plus that one, is positive. So if this, the rest of the expression inside the parenthesis is positive, then we have this is greater than 1 plus a positive number, which is still greater than 1. So it is enough to show that this plus those three terms are positive. Okay, So we say that to show LHS greater than 1, it's enough to show that this minus that 3k plus 2 over plus 1 over 3k plus 3 plus 1 over 3k plus 4 minus 1 over k1 is possible. So if we are able to show this, then basically we are done, because the left hand side will be a positive number plus a number that is bigger than 1, which is still greater than 1. So before we discuss this, you might want to try by yourself to prove this assertion, to prove this inequality. So go ahead, pause the video and give it a try. I will come back again in a couple of seconds. Okay, so how is it? Let's do this on this side while you can still trying to work out that inequality. So first we're gonna rewrite this expression so that we can also have 3 terms to somehow compensate these 3 terms, the positive 3 terms. So notice that the last term can multiply the top by 3 and also the bottom by 3. Right? So we have 3 times of 1 over 3k plus 3. And then we will split them. So 1 over 3k plus 2 minus 1 over 3k plus 3 plus 1 over 3k plus 3 minus 1 over 3k plus 3, and then plus 1 over 3k plus 4 minus 1 over 3k plus 3. Okay, so this left hand side of this inequality, because this guy is nothing but 3 times of 3k plus 3, so that 3 times of 1 over 3k plus 3 is split into 3 terms, right? Okay. So now this guy is equal to 0. So we just left with this plus that. But if we simplify this, if we try to make the denominator to be the same, it's going to be 3k plus 3 minus 3k plus 2. Okay, so it's going to be 1 over 3k plus 2 times 3k plus 3. And then on this side, we have minus of 1 over, 3k plus 3 minus 3k plus 4 is negative 1. So negative 1 of 3k plus 4 times 3k plus 3. Okay. Now notice that this 3k plus 2 is smaller than 3k plus 4. So what does that information helps us? So it means that 1 over 3k plus 2 will be bigger than 1 over 3k plus 4. Okay, so this expression is bigger than this expression. Therefore, the difference is positive. Okay, so we are done. And then you can write it down neatly so that we can have some more direct proof instead of going a tangent first like this. So like, for example, after we reach this point and then we rewrite, so okay, let's see, after we do this analysis, this is to write down the proof nicely. So we're still looking with the left hand side, and then we say that this is equal to 1 over k plus 1 plus plus 1 over 3k plus 1 plus this is exactly what we wrote down over there. 1 over 3k plus 1 minus 1, sorry, 3. 3k plus 3. And then 1 over 3k plus 4 minus 1 over 3k plus 3. And then we write this as 1 over 3k plus 1 plus this guy plus 1 over 3k plus 2 3k plus 3 minus 1 over 3k plus 4 times 3k plus 3. And this is bigger than 1 and this is positive. So the whole thing is positive. The whole thing is greater than 1, which is what we really want for n equals k plus 1. So that's all guys for now. Thank you very much for watching. See you again on the next video. Don't forget to subscribe if you haven't done so. See you again. Bye bye.